So a big warm welcome to all of you. We don't have a lot of people with us this evening, but hopefully everybody else will join. Maybe they're still joining us a little bit later. So this is our final session on the cubic function. We will revisit this topic again when we do exam revision, but as of next week, we're going to go on and we're going to talk about financial maths. Okay, and then we're going to have 6 lessons on that. So this is the last one. So because it's a Thursday, it means it's quiz day. So there will be a small quiz that you guys need to go and answer after this. And both Nelisa and I want to really encourage you to go and do the quiz. It gives you an idea of what you know. It gives your parents an idea of what you know. You can sort of redouble your efforts and sort of look at the things that you need to focus on. So please go ahead and go and do that. At the end of the lesson, Nelisa will post the link into our chat. Okay, all right, let's get started. This first question is not something that I've done with you, but it should be something that your teachers have done with you. So what I want to have a look at today is the sort of basic types of exam questions that we would get and be expected to be able to answer on this sort of section. All right, so we know that whenever we've been given a diagram in maths, no matter what section we're working in, we don't look at the diagram first. Okay, we look at the writing and the information and we see if there's anything that we can see in front of us that we can tie to the picture. Maybe there's coordinates we can write down or lines that we can say are equal or parallel or whatever the case is. All right, but anyway, not in this case here, but maybe there's coordinates or there's some sort of important information that we need to answer the question. So always read the question first carefully. It says to us the graph defined by f of x is x cubed plus ax squared plus bx plus c is shown along with its tangent. Okay, so g of x equals mx plus c. Both graphs cut the y-axis at D and intersect at C. The graph of f cuts the x-axis at -3, 2, and 5. Okay, A and B are the turning points of f. All right, so the first question that they ask us, so all they've given us are 3 x-intercepts. We don't know the coordinates at D, we certainly don't know the coordinates at A, and we certainly don't know the coordinates at B. The other thing that's missing is both equations. All right, so we do not know the values of A, B, and C, or M. The first thing that they say to us in number 1, and this is a very popular first question, that's why I chose this particular question to do with you. Show that A equals -4, B equals -11, and C equals 30. Right, so now I want to talk a little bit about this question. Before we actually get into the how, I just want to point something out to you, which is something you guys probably know by now, but I'm just emphasizing the things that are important. In maths, and again, in any section, it doesn't matter whether you're working in geometry, whether you're working in analytical geometry, whether you're working in functions, whatever section. In maths, when the question says, show that, right, and then they give you the answers, you need to attack the question, pretending like you didn't know that those were the answers. Okay, so that means you cannot take what they've given you and sub it in, because then you're not showing or proving, you're verifying, and that's something completely different. Okay, so in our CAP syllabus, we don't verify. Okay, we prove or we show that, but we don't verify. So you cannot sub that information in. All right, you have to work out those answers like you didn't even know that they were the answers. Okay, which is the first thing that I want to make clear to you. The second thing is that we know that A and B and C are coefficients or a constant term in our graph of f of x. The only thing that they've given us is -3, 2, and 5. Now, there's something that we need to use in this situation. We've been given 3 distinct roots. Now, the equation we're going to use is not on your formula sheet, which is why we always say as maths teachers, by the time you get to matric, maths really is a learning subject. And it certainly is, because if you don't know what equation to use here, you're never, ever going to be able to answer the question. Does anybody know what it is that I'm referring to? What would I use for question 1? Has anybody got an idea? Even if you think it's wrong, it doesn't matter. What would you do? What do you think you should do? Okay, let's see. Someone said something. Okay, so Tamika says differentiate. Tamika, in certain situations, you're 100% right. The option is to differentiate. But here, what you've got to bear in mind is that there are ways to do things. And if you do something that doesn't lead to a solution, even though it might be true and it might be fair and it might be real or whatever the case is, if it doesn't lead to a solution, you're not going to get any marks for it. Okay, so in this case, differentiating is not going to take you anywhere, unfortunately. Let's have a look. Okay, so now, Cassandra, look at this, guys. Are you looking in the chat? I would open 3 brackets and sub in my x-intercepts. So Piso says, I would multiply x plus 2, x minus 2, and x minus 5. Amanda, yes, there we go. All right, Amanda, why are you not 100% correct? Okay, what you have suggested here is for what? I'll let you think about that. Okay, so we can't differentiate, unfortunately, Chantal. We don't have any information here to be able to sub in. We don't have another point. We don't have the equation of the derivative. So there's nothing for us to be able to work back to the original. Okay, so what Tsepiso said and what Cassandra said is 100% correct. Amanda, you are on the right track. But we use x minus x1 times x minus x2 squared when x2 is a turning point and an x-intercept. Okay, does that make sense? All right, so what we would do here, exactly as Tsepiso and Cassandra had said. All right, this is the formula. I'm just writing it down so that you guys, those of you that didn't know this, that you've got it, right? So in number 1, you are doing y equals a x minus x1, x minus x2, x minus x3. Now this guy is not on your formula sheet. Okay, so you need to know that you've got to learn that. Okay, so that's where cubics come from, isn't it? It's by multiplying x together 3 times. So it's 3 brackets. And there are your 3 distinct roots. So as Tsepiso said, we are going to use minus 3, 2, and 5. Now, the other thing that I want to point out, all right, is that they have told us very specifically, if we have a look here at the first term, what is the coefficient of the x cubed term? What is the coefficient of the x cubed term, Matrix? What are they telling us here? Yeah, there we go. Well done. Yeah, 100%. It is 1. Okay, so normally we would have to calculate it. All right, we can't just assume that it's going to be 1 or 2 or whatever the case is. We would actually have to calculate it. But in this case, we know that it's 1. They've told us that it's 1. When they write there f of x equals x cubed, we are allowed to assume that they are saying to us that the coefficient of x cubed is 1. So this a value over here, this is the coefficient of the x cubed term. And in this case, it is indeed equal to 1. So that's why I'm going to put 1 there, even though it doesn't change anything. And then here we have x plus 3, x minus 2, x minus 1. Is that correct? Let's just go and check. Oh, no, sorry, that's not right. It was 5. Sorry, let me just change that to 5. Okay, so that's exactly what Tsepiso and Cassandra said. Now we have to multiply it out. Okay, so I've done the first bit for you. You guys multiply it out. Let's check you've got the right answer and we can move on. Okay, so you're going to multiply that out quickly. Let's check what you've got and we move on. Okay. So I'm just repeating what I was saying to Primrose, who missed what I said. Primrose, they've asked us to determine or asked us to show that A equals -4, B equals -11, and C equals 30. Okay. And what I was saying here is that you need to, first of all, approach this question like you don't know that those are the answers, okay? Because you're not allowed to sub them in. Then you're not proving, you're verifying, and verifying is different. So you have to pretend like you don't know that those are the answers. And when we have been given 3 distinct roots in a cubic equation, all right, this is the equation that we use in order to be able to work out the equation. All right, so we use y equals a, x minus x1, which is x-intercept number 1, x minus x2, which is x-intercept number 2, and x minus x3, which is x-intercept number 3. Okay, we've then got to go and sub in our x-intercepts. I had also said that if we went up here and had a look, that there was an invisible 1 in front of the x cubed, and that we were allowed to assume that the value of a, so when I say a, I mean this a over here, should have probably not called it A, maybe I should have called it D, is going to be equal to 1. Okay, because the coefficient of the x cubed term is 1. Okay, so we go and sub those in, multiply them out, and we should get what they give us. All right, are you guys getting that? I certainly did when I multiplied it out. Okay, so we would end up with y equals x cubed minus 4x squared minus 11x plus 30. I'm just going to have a quick look in the chat and see if you guys have done the same thing. Yeah, okay, nice everybody, well done. Yes, sure, that couldn't have been easy to type, and there's so many of you that did it. Well done, that's really great. Your participation is amazing. Thank you so much. Lovely work, everybody. Okay, so that's how we would show that. So yeah, bear that in mind because it's often one of the first questions, and if not here, then maybe in functions as well. All right, second question. Now we should be on sort of familiar ground here. They want us to determine the coordinates of A and B. What do A and B represent, Matrix? They are the... Let's have a look. Indeed, indeed, they are the turning points, quite right. Okay, so what do we do for the turning points? How do we get the coordinates of the turning points? What do we have to do here? Yes, we have to that's it, Kanisa. Yes, Juanita, 100%. Okay, so we're going to differentiate first derivative. Quite right, Elam. Okay, first derivative. Yes, Leah Borna. Okay, so let's find the first derivative. And we're going to, yes, Amanda, and we're going to make it equal to 0. I'm going to let you guys do that. And then you're going to show me what your x coordinates are at the turning points. And we'll check there. And if that's all okay, then we'll move on. Okay, so you guys, yes. Letu yende, f prime x. Yeah, and this one, f prime x. Okay, so go ahead and do that. Solve for the x coordinates. At these points, we'll check, and then we'll move on. Okay, so we're taking the derivative because we're working with the turning points. The gradient at the turning points is 0. We're going to make it equal to 0, and then we're going to factorize or use the quadratic formula, and we're going to check our x coordinates at our turning points, and then we are moving on. Let's see. All right, Piso. I didn't press the SD button on mine. I'm just going to check that. But I think you're right, Piso. Yeah. Okay. Same answer as you, Tapiso. Namfundo, I got the same answer as you as well. Okay, good job. Well done. Right, you guys can continue to find the y coordinates at those points if you want to. Tapiso and Namfundo. Let's see what everybody else is doing. Yes. Nsika, lovely. Yes, good job. Good job, good job. Yes, Primrose. Yes. I got the same answers. Yes, Tato. Good job. So I just absolutely love the way you guys are prepared to share answers. That's really, really amazing. Thank you so much. Good work, everybody. Okay, so I'm going to do that too. Just because, not because I need to correct anything, what you guys have done is perfect. I just want to emphasize a couple of things. Okay. First of all, you must show that you made it equal to 0. Okay, so many matrics lose marks like that. So first derivative, we're going to write our first derivative. We're going to apply our power rule to each of our terms. And we must show that the derivative is equal to 0. Okay, so it's really, really important that you show this line over here, matrix, where I'm putting the tick, and that you show this over here where the 0 is. Okay, very, very, very important. Otherwise, even if you go ahead and go and factorize, if you leave stuff out, you're not going to get full marks. Okay, and that's something that often gets left out. So very, very well done to all of you that did that. And then, of course, here when we factorize, or if factorizing is not your thing and you want to use the quadratic formula, of course, there's nothing wrong with that either. So I quite agree. I also got 11 over 3, or x is equal to -1. Now, what do we do with these x values? What do we do with those? Oh, Namfundo is already giving us answers here. Okay. All right. Namfundo, you're on fire today. I love it. Okay, so Namfundo says that A is -1 and 36. Cool. You do, Kanyisa. You substitute them into the original. Yes. Good, Cassandra. Good, Chantel. Yeah. Yeah, absolutely. Well done. Okay, so go and sub those in, and you should also show that as well. Okay, so here what you should show is f of 11 over 3. I'm sure this is how your teachers have taught you to set it out. So it's just a matter of subbing it in and then letting the calculator do the rest of it. And of course, if you're going to put in a horrible fraction in like 11 over 3, we're kind of expecting some kind of nasty fraction out as an answer as well. So I certainly would in this case. And then f of -1 . Okay. And let's see what you guys say. Okay, so good, yes. Okay, Neo, I see. Sabu, yes, lovely. Chantel, beautiful work. Neo, lovely. Those are the coordinates at A that you put up there. Very, very nice. Okay, well done, everybody. Okay, so yes, certainly that's -14,81. I quite agree. And then here we got 36. Okay, and then our final step here, Matrix, sorry, would be to actually say what the coordinates were, because they said to us determine the coordinates at A and B. All right, so very nice. We chose that A would be the one where -1 is, and 36, because we can see that A is a point in the second quadrant where x is negative. And then as far as B is concerned, we can see that that is a point in quadrant 4. So we are expecting a positive x and a negative y. Okay, so it makes sense that we ended up with our ghastly 11 over 3 and -14,81. Okay. Yeah, Leah Borner, that's probably a better way to write it, that -400 over 27. I'm going to copy you. Okay, -400 over 27. Yeah. Although there's nothing wrong with rounding it off, but yes, perfect. Good job. Okay, nice one. Nice one, nice one. Because this, guys, this is like 5 easy marks. Okay, or should be 5 easy marks. So you would definitely get an answer for that. Another one for, would you get a mark for subbing in, and then your B values. Okay, so that could be 5 easy marks for you. Okay, 5 easy marks that you must get. Excellent. Now they want us to determine the equation of G. Now again, this is not something that we've done together, but it is something that you would have done in class. All right, and just to go back and refresh our memories, G of X is a tangent, okay, to the graph. All right, so why am I emphasizing the word tangent? Okay. So a tangent, so if a line is a tangent to a function, it touches it in one place. It's a straight line, absolutely. All right. Now, quite right. It is a straight line. All right. What can I say about the value of C? And I'm talking about this C over here. Let me just highlight it for you. This C here. Do I know what that is? Yes, it's the y-intercept. Absolutely. It is the y-intercept. And I know its value in this case. Yes, Tamika, you're quite right. Yes, Tippy, so it is 30. Okay, because we calculated that, well, we showed that up here, didn't we? We determined that as well. Okay. So yes, most definitely, we know what the y-intercept is, right? So if we've got the value of C, the other thing that we need to, yes, it's the constant in your equation, quite right, Chantal, quite right. The other thing that's expected of us here when we are determining the equation of G, what else do they want from us? They want to know the value of C, and they also want to know the value of? Exactly, exactly. And what does M represent, everybody? M is? Exactly. Okay, it's the gradient. It's the gradient. Okay, and the gradient is the first. Perfect. Lovely, lovely, lovely. Well done, everyone. That's great. It is. It's the gradient. It is the first derivative. The first derivative is the gradient. Okay, so we want to know what the gradient is at D. Okay, we want to know what the gradient is at D. What are the coordinates at D? They are 0 and 30. So we want to, oopsie daisy, why is my pen doing that? We want to know what the gradient is at D. I'm kind of dropping big hints here now. Okay, what am I going to do? How am I going to work out the gradient at D? Anybody know what I can do? Remember, the gradient is the first derivative. I'm going to write that down here for you guys as well. The gradient is the first derivative. So M is gradient. It's f prime x. It's the first derivative. Hint, 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 hint. Ooh, there we go. All right, we're going to sub my x and y into the first derivative. Okay, do you have to sub in the y, Cassandra and Juanita? Do we need the y? That's right, Andiswa. Okay, but we only need the x. Okay, because remember, our first derivative is in terms of x, isn't it? It's f prime x. So into f prime x, which we determined in the previous question, which is 3x squared minus 8x minus 11, we want to know what is the gradient at D when x is 0. Okay, so we are calculating f prime 0. Does that make sense to everybody? So I'm going to sub in my 0. If I wanted to know the gradient at another point, I would need a different x value. Okay, but it just so happens that the tangent touches the graph at the point D where x happens to be 0. Does that make sense to everybody? Okay, so in this case, we don't need to sub in the y. Okay, if we don't know what the c value is, and we're working with y equals mx plus c, then we need the m and the x and the y to work out the c. But we know what the c is in this case. So that's why we don't have to sub the y in. All right, so we know that 0 minus 0 is going to give us 0 minus 11 gives us negative 11. Good. Yes, well done. So therefore, g of x is the equation minus 11x plus 30. Oh, that's nice, everybody. Sure. Good. You guys are doing so well. This is beautiful maths. Good. Now, another one. Determine the coordinates. And hang on, let me see. Okay, so there's lots of thumbs up there. Okay, nobody's put a thumbs down or a sad face. Okay, I'm glad you're all doing well and you're feeling good. I'm so pleased. All right, let's go on and do this next question. So in number 4, it asks us to determine the coordinates of C. Now remember, C is down here. Okay, so I'm just going to highlight it for you. What does C represent? What do we call that thing that C is? Aha. Sure, you guys are on fire. My word, well done. Yes, it is a point of intersection. So when we want to find the coordinates, we absolutely, well done. Nice matrix. Point of intersection. So when we want to find the coordinates at a point of intersection, we have to let f of x equal g of x, or whatever it is that we've been given. Okay, so for a point of intersection, indeed, Tulusile, you are quite right. It is a point of intersection. So what we have to do here, let's just see who's number 4. All right, so at number 4, let's choose a different color. What should we choose? Green. Okay. All right. So we have to let f of x equal g of x because it is a point of intersection. Okay. So the two are equal to one another at that point. Okay. So now our cubic, x cubed minus 4x squared minus 11x plus 30. And we have to make that equal to negative 11x plus 30. So now to find the coordinates of x and y, we have to solve for x. I'm sorry, my squares are dreadful. If each year that goes by, they get worse and worse and worse. There we go. Let me write that a little bit better. Okay. So now, in order to work out what the value of x is at the point of intersection, we're going to have to put this into standard form, make it equal to 0, and after that, we have to factorize. Okay, so let's get this into, what do we notice straight away, right? If I take my minus 11x over to the other side, this term is going to become 0. And if I take my 30 over to the other side, that term is going to become 0. So what am I left with? X cubed minus 4x squared is equal to 0. Does that make sense to everybody? Okay, so this is actually going to be easier than we thought. Okay, because the minus 11x adds up to 0 and the 30 adds up to 0. Okay. So now we have to factorize. We're going to have to factorize by taking out a highest common factor of, what do you think in this case, matrix? What's our highest common factor? X squared. Yeah. Quite right. Okay, yes, x is a factor. You're quite right. X is a factor, but x squared is the highest common factor. Okay, so we're going to take out, indeed, Yolisva, we're going to take out x squared. Okay, and that's going to leave us with x minus 4 equals 0. Okay, you guys are doing really well. Yes. Oh, look, there you go. You've got answers already. Oh, my goodness. Well done. So either x squared equals 0 or x minus 4 equals 0, which is not actually a step we need to show. So yes, either x is equal to 0 or x is equal to 4. Okay, so now we're going to go back up and have a look. Is everybody cool with that? Nice, 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 matrix. Excellent work. So now let's go back up and go and just recheck our question. What we were asked for coordinates at a point of intersection. Let's just go and have a look where that point of intersection is again, because we've got 2 answers now. And obviously, x can't be 0 and 4 at C. So we're going to go back up and we're going to go and have a look. Well, we're feeling really good about what we've done now because we know that we were supposed to get 0 as an answer because the graphs intersect at D where x is 0, don't they? And the only other place where they touch one another again is at C. And that is a point in the 4th quadrant where we know that x is positive. So right now, our answer is making a lot of sense. We feel confident. We're happy with the questions, with the answers that we're getting. We feel good about this. Now what we need to do is we need to make a choice. All right. So here you've got an option. Either you put a line through that, or your option is to say at C, x equals 4. Okay, but you just need to indicate that you are choosing 4 as your answer for C. Okay, and then you're going to go and sub it back in. Either you can sub it into the cubic, or you can sub it into the straight line. Make your life easy, sub it into the straight line. So essentially, remember our straight line is the line g of x. So we are calculating g of 4. Okay, because we want to make our lives easy and less complicated. Okay. And we're expecting a negative y answer. So we've got negative 44 plus 30, and that gives us negative 14. Good. Oh, wow. Look at that. Juanita's got it. Nomfundo's got it. Anga's got it. Tato's got it. Sure. Sabu. Sure. Nice, guys. Lovely. Perfect, Amanda. Good, Kanisa. Right, Andiswa. Yes, Elam. Yeah, me too, Chantal. I also agree. Even me. Okay. All right, so at C, the coordinates are 4 and negative 14. Yeah, boy, yes. Quite right. Very, very nice, Matrix. Lovely work. Okie dokes. So we have done number 1, number 2, number 3, number 4. All right, now we need to determine the gradient of the tangent to F at its point of inflection. Okay, so we want to calculate the gradient of the tangent to F at the point of inflection. Does anybody know what that represents? The gradient of the tangent at the point of inflection. Any ideas of what that represents? Okay, so the gradient, okay, let's see, someone's put an answer up. Yes, Elam, okay, in order to calculate the x-coordinate at the point of inflection, we need the second derivative, certainly. So that's going to be part of our answer. We need to calculate the second derivative. But the gradient of the tangent at the point of inflection, what this represents, it represents the, let's see if somebody else has said it before I've done. Yeah, shame there's there's lots of things here. Stationary point. Leroy is saying derivative minus, okay, second derivative. What it actually represents, I mean, maybe your teachers have not discussed this with you, but the gradient of the tangent point of inflection represents the maximum gradient of the tangent. This may not be something that you've come across before. Okay, but even if you don't 100% understand what it means, you could still calculate it, okay? Because you know how to calculate the x coordinate at the point of inflection, don't you? And you know how to take that x and sub it into the first derivative. Okay, does that make sense to you? So we're going to use the second derivative or midpoint formula to calculate the x coordinate at the point of inflection. Once we've got that, we're going to take that x and we're going to sub it into the first derivative. Okay, the first derivative, remember, it represents the gradient at a point on the cubic. Okay, does that make sense to everybody? So we can choose here. We can either do the second derivative or we can do midpoint formula. Okay, the choice is up to you. I think often midpoint formula is a little bit quicker and easier. Yes, Leoborna, it's a difficult concept to understand, but basically when you are calculating the gradient at the point of inflection, that is the maximum gradient, the biggest possible gradient that the cubic function can achieve between its turning points. And that happens at the point of inflection. So, but yeah, don't get too caught up on that. I mean, this may not be something that they ask you. This is a little bit of extension work. Let's work out what the answer is. Okay, so f double prime x, that is, I guess we've got to derive the derivative. So that's going to give us 6x minus 8. Is everybody happy with that? So second derivative is 6x minus 8. At the point of inflection, the measure of concavity is 0. So this means that minus 6x equals minus 8, and dividing both sides by negative 6, we would end up with 4/3. Okay, or the other way to be able to do this is we've got minus 1 and 11/3, sorry guys. So minus 1 plus 11/3 all divided by 2. We should get the same answer. Let's just check that we do. Yeah, well, yes. Okay, good stuff. It's also 4/3. Yeah, Chantal, they do sometimes ask questions like this. I have seen it before in exam papers. So I know I've seen it in our trials papers at my school. So, I mean, and that's why I suppose it's good that we do all these sorts of questions, you know what I mean? Because it just, we here at Watobe, we are consolidating the things that we know you're going to be asked. And the information that you need to be able to access the questions. And then it's also nice for us to be able to do a little bit of extension work and just look at, okay, well, what if they gave us this, or what if they gave us that? Okay, so yeah, I always try and do that. So now we've worked out the x coordinate at the point of inflection. If we now want to work out the gradient at the point of inflection, we have to sub 4/3 into the first derivative. Remember, the first derivative is the gradient at a point. Okay, the gradient at a point. So this is 3/4/3 squared minus, was it 8? I think it was. Yes, minus 8x minus 11 minus 8 x minus 11. Okay, and now we want to work out the answer to that. Yeah, I'm getting that too. Okay, quite right. Quite right, guys. Okay, minus 49 over 3 is indeed the correct answer. Okay, so that is the steepest that the graph can be, this particular case. Yes, Andiswa. Yes, Elam. Nice, well done. Good job. Good job, everybody. Okay, let's go back and see if we can finish this question. Okay, so we've done number 5. Let's look at number 6. Okay, determine the stationary point on the graph of y equals f prime x. So now these questions are getting a little bit more difficult. Okay, so the stationary point on y equals f prime x, what are they referring to? What is the graph of y equals f prime x? What is that? It's the graph of y equals f prime x is the graph of what matrix? Anybody know? Yes, absolutely. It's the graph of the first derivative. So it's P, so the first derivative is 3x squared minus 8x minus 11, isn't it? So what is the graph of the first derivative? The graph of the first derivative is a? Yes, exactly. The graph of the first derivative is a parabola. 100%. 100%. Okay, the graph of the first derivative of a cubic function is a parabola. So what are they really saying to us? They're asking us to work out the coordinates at the stationary point, which is the turning point, of the first derivative of the parabola. So now we've got to think back to grade 11, okay? Because this is super easy. We can do it using calculus, but there's an even easier way. Does anybody know? There's, again, another little formula. It's not on your formula sheet that we can use in this instance. Anybody know what I might be referring to? Ah, there we go. There we go. Well done. Yes, Cassandra, it is the equation x equals negative b over 2a. Do you remember that matrix? Okay, so that allows us, that's it. Good, guys. Nice. It allows us to calculate the x coordinate at the turning point. And then again, if we take that x coordinate and we go and sub it back in, we'll get the corresponding y. Okay, so that's what we're going to do in this case. So x is equal to negative b, so that's negative 8 over 2 times 3 in this case. All right, so we end up with 4 over 3 again. Okay, we should know that because it's going to be the same as the point of inflection. Okay, it's the same as your point of inflection, isn't it? Okay, so the turning point on the first derivative, on the graph of the first derivative, it has the same x value as the point of inflection on the cubic. All right, and we can see that by what we've calculated. So now we have to work out what f prime 4 over 3 is. Have we done that? Yeah, we've worked that out. Okay, so there, minus 49 over 3. Okay, so actually all we needed to do was write this down. Okay, so they shouldn't have said determine, they should have said write down. That's not a very good question. Okay, well, it's a good question, it just phrased badly. Okay, so here. Okay, so the coordinates at the turning point are going to be minus 4 over 3, sorry, positive 4 over 3 and 49 over, was it 8? Sorry, this is the only thing about working online, minus 49 over 3, sorry. About working online, that's just a bit difficult. We kind of have to move around a bit. So minus 49 over 3. Orotile, you would use x1 plus x2 over 2 to find the coordinates at the point of intersection. Oh, sorry, I see Elise has answered you. Okay, all right, good. So yeah, that shouldn't have said determine, it should have just said write down. But anyway, it doesn't matter, we've got that answer. Okay, so now let's go and have a look at these guys for the remainder of our lesson. Although, mind you, we're going to have to finish by about 5 too, because you guys need time to go and do the quiz. So we'll just do a couple of these, because these sorts of things come up. And to be honest, they frighten so many matrics. Like, so many people look at that and they're like, what on earth does that mean? And once you actually begin to understand what they're referring to, it's actually not that difficult, but you need to understand what it means in order to be able to answer the question. Okay, so maybe I'm just going to be able to do 3 of them. So I tell you what, I'm going to have a look at I'm going to have a look at number 1. I'm going to have a look at number 3. And let's have a look at number 5, and we'll see if we can do those. All right. So in number 1, okay, now again, do you remember our first lesson on this where I was talking to you about where is f of x positive, where is f of x negative, where is the first derivative positive, where is the first derivative negative, where is the second derivative positive, where is the second derivative negative? That's why we spoke about that, so you can do these questions. So here, this f prime x, what does that mean in simple English? Nothing, no fancy maths speak. What are they asking us here? For which values of x is? Aha, so y negative. Good. So y is negative below the x-axis, isn't it? So y is negative below the x-axis. So here, this is where you're looking. Okay, you're looking at your critical values. Okay, aka your x-intercepts. All right, and we can see that outputs on this cubic function are negative when x is a number that is smaller than -3, or when x is a number that is bigger than 2 but smaller than 5. Good job. Well done, guys. Yes, where it is negative. Does that answer make sense? Okay, so smaller than 3 or between 2 and 5. So that is the answer for number 1. For number 2, they're asking us, what does this mean? F prime prime x greater than 0. What are they asking us when they give us that? Yes, so yeah, positive concavity. Good, Michael. Good, positive concavity. Remember, the second derivative is concavity. So it's saying for which values of x is the graph concave up? Okay, so remember, this one is first concave down and then concave up. So the values of x, which it is concave up, is going to be the values of, whoopsie daisy, let me just write in a proper pen, where x is greater than 4 over 3. Okay. So that's where it's going to be concave up. And then the last question that we're going to manage to do, what are they asking us for here? So f of x times f prime x is smaller than 0. What does that mean? Okay, so f of x times f prime x smaller than 0. So f of x is output. Output times gradient is smaller than 0. Now remember, these are numbers. Output is a number. Okay, it's a measure of something. Okay, so is gradient. Okay, it's a number. So now we're multiplying two numbers together and we want a negative outcome. So now back to grade 8. When we want a negative outcome, either one has to be negative while the other one is positive, or where the one is positive, we have to look where the other one is negative. Okay, so either we have to be walking uphill below the x-axis. Does that make sense to you? We have to be walking uphill below the x-axis. The gradient is positive while output is negative. So this bit over here means we are walking uphill below x-axis. And over here, we have to be walking downhill above the x-axis. Okay, so where are we walking uphill below the x-axis? Where are we walking downhill above the x-axis? Okay, so we are walking uphill below the x-axis. Let's choose a better color. Let's go pink. Over here, I'm walking uphill below the x-axis. Gradient is positive, but output is negative. Okay, here we are walking downhill. Okay, gradient is negative, but output is positive. And then over here, gradient is positive, output is negative. So it's in these places here only where that is happening. Okay, so how will I write that answer? I need to know the coordinates at A and B again. Remember, A was -1 and B was 11/3. So this was -1, that was 11/3, the x coordinate. So this is going to be, so for number 5, it's going to be where x is smaller than -3, or where x is bigger than the x coordinate at A, but smaller than 2, or where x is bigger than 11/3, but smaller than 5. Okay, that is an awful lot to take in.